Hi there. In this video we are going to look at one of the learning objectives that you need for the test. So calculating power using Ohm's law, or sometimes we have the resistance and we want to calculate power. But first, let's have a recap on Ohm's law. What do I mean by that? Do you remember we have this triangle for voltage, resistance, and the current. So resistance is voltage divided by current. So if I am going to look for resistance, put your hand on R, the voltage is on the top and the current is on the bottom. And for the students who are not Dutch, remember that U is V, voltage. So you use different symbols for voltage, that is V. But in Netherlands, the symbol for voltage is U. So resistance is voltage divided by the current. And when the resistance is constant, which we say that we have an ohmic resistor, current and voltage are directly proportional, and this is called the Ohm's law. So Ohm's law means that the resistance is constant and the voltage is directly proportional to the current. So if we double the voltage, the current will be doubled. So this is what we have for the resistance, voltage, and the current. And don't forget, another name for voltage is the potential difference. We have also this formula for power. Power is voltage times the current, or current times the voltage. Like this. So let's have a look at this question here. Calculate the resistance. So we are looking for R. Calculate the resistance. What are the given data? 12 volts. 12 volts means that this is voltage, because a volt is the unit of voltage. So this is U. And power, watt here. So this is a power. So the given data is voltage, 12 volts, and the power is 36 watts. And the question is calculate R. So when we look at this formula here, if we want to calculate R, we need these two. We have the voltage, but we don't have the current. But what we have here is a power. So that means that first we need to calculate current using this formula. So I'm going to use this formula. Let me put it in the triangle for you. Might be a little bit easier to handle. So we have power here, we have current, and then we have the voltage. And I am going to work out the current. So put your hand on I. P is on the top, U on the bottom. So I is P power divided by voltage. So power is 36 divided by 12. The answer is 3 and the unit is amps. Now that I have the current and then I have the voltage here, like this, I can calculate the resistance. So resistance is voltage divided by the current is 12 divided by 3, and the answer is 4. The unit is ohm. And then we can have a look at another question, this one. In this question here, we have a resistance of 17 ohms. So this is all what we have, and is used on a 230 volts mains supply. So these are the key words telling you that this is voltage. So voltage is 230 volts. And what are we looking for? We are looking for the power. Find the power to two significant figures. So we are looking for power. But if I want to calculate the power, I need the current and the voltage. Here I only have the voltage, I don't have the current, but I have the resistance. So that means that I can use this formula over there. So first I calculate current. So put your hand on I here. I is voltage divided by resistance. So is voltage divided by resistance, which is 230 divided by 17. So let me get a calculator. Here. Divided by 17 is 13 point and the unit is amps. Now that I have the power, I have the current, I can calculate the power. So power is current times voltage, which is 13.6 times 230, and the answer is times, oh, that was actually 13.5. Okay, so this times 230. Okay, so this is the answer. And did I do that correctly? Because that doesn't sound right. Okay, 13.5 times 230 is what was that? 3,105. And two significant figures means that I can write it down like 3.1 times 10 to the power of 3, and that is 3.1 kilowatt. So I wrote it down in scientific notation, which is 3.1 times 10 to the power of 3, and 10 to the power of 3 is kilo, and the unit of power is watt. So the answer is 3.1 kilowatts.